Good afternoon. My name is Martin Levy. I'm from a company called Hurricane Electric, and we spend an awful lot of our time focusing on IPv6. So the core topic is IPv6 this afternoon, and I know it's always very hard to talk immediately after people have had lunch, but that's only a little bit harder than listening after you've had lunch. IPv6 is a subject matter that is front and center when it comes to communicating on the global internet. But it's not front and center when people say, yeah, but the internet just works. And what I'm here today is to sort of convince you otherwise. So in theory, I could put 50 or 60 slides up that say why we need IPv6. But the reality is that it's 2012. And if I'm talking to a technical audience that has, an internal view of what the internet does versus a cursory sort of web browser, Facebook view of what the internet does, I mean, this shouldn't be a new subject. So technically, I'm not going to talk about it. Just, I'm going to assume it. Reality is there's a hell of a lot of stuff on the web about this subject that goes into excruciating detail. There's actually about 50 slides on the back of the presentation I'm going to give you, which I presume will be uploaded onto, it was emailed in, it should be uploaded on the website, and that, again, covers a lot more of the substantiation. But the substantiation actually can be really summed up pretty easily. We've run out of v4 addresses. It's just that at the end user, we haven't really noticed yet. So one of the things I'm going to really do is just talk at a very high level about why that happened and what that happened, and then talk about what's going on, which is far more important, a forward-looking into what's going on in the world from a v6 point of view. I'm going to talk about it to a little extent on what we've been doing for 11 years, but at a really high level, trying desperately not to make it look like a marketing talk. I'm not in marketing. I'm a techie. And then finally, I'm going to talk about motivation tools, and maybe there's some takeaway for people who need motivating, and that you can see what we've done in this regard. So let's talk about those 11 years. And you've got the usual sort of list of things that have gone on, but there's some key points that we've dealt with. One of the most important points, I've got the classic laser here, is that we jumped the gun. And we did something that very few other companies did. And way back 6 years ago now, when we were doing a technology refresh on the core of our network, we turned around and said, everything must be v6. And the vendors turned around and said, yeah, maybe not. And so the battle began. How to go ahead of the curve and get absolute parity between v4 and v6 delivery in what is actually the easiest thing to do that in, the core of the network, core routers, the ability to move IP packets between one media and another, between one Ethernet and another. But we pulled it off, and we started to build very quickly. And it turns out if you focus on this, you actually end up becoming the largest IPv6 backbone. Now, you're still moving a lot of v4 bits. In fact, you're moving an enormous amount of v4 bits. But every bit that's v6 is a replacement for a bit that's v4. So you aren't sort of generating new traffic. But when you talk about sort of hitting a gig of traffic in 2008, you've got to realize that if you were to graph that, it wouldn't even be a pixel on top of the v4 graph. It was a tiny, minute amount of traffic. And in fact, one of the big problems that people had in 2008, and you'll see what happened later, is that people said, well, this isn't that important. Everything else seems to work, so we'll just continue as is. So you actually have a really hard time back, that many years ago, trying to talk to people about v6. Well, we did a lot of other stuff, like we threw in DNS. We did some 64 services globally. This was all about getting the global internet, not so much in the private enterprise or the private network space, but in the global network, ready for v6. And we actually took a very simple mantra. And this took a long time to convince other people to do the same. And it's a very simple mantra. If there's a packet flowing and it has a v6 header versus a v4 header, it's just as important. That 1 gigabit of traffic globally is just as important as the terabits of traffic that you're moving day in and day out. You just don't want to make somebody's first experience with v6 to be a bad one because you have a substandard method of moving bits around, or you just don't care that much about it, or it trombones across the Atlantic backwards and forwards when it really isn't meant to. This was a key point, and what happened with that is that we ended up getting people convinced that v6 worked, and as time went on, more and more people came into that place. Look at that timeline from a pure v6 point of view. If you actually look at where we are with IPv6, you've got to go all the way back to 94 and then 95 to the IETF. And back then, this realization that we had to change the IP protocol. Now, in retrospect, you can come up with some interesting, oops, we didn't quite do it right. But revisionist history, or complaining about what you thought 10, 15 years ago, the scale issue was not understood. So you get down to about 2000, 2001, and you actually start getting a Cisco router with a special image, or a Juniper, that can actually route a v6 packet. Not very efficiently. But you can throw a couple into your network, and then you realize that other people have done the same, and you can start setting up either a direct connection or a tunnel of some variety. And so you end up with this sort of actual operational experience, but you would never provide this to a customer. You'd provide it to a research network. You'd provide it to somebody who's very curious, but you wouldn't ever think of moving production traffic. And really that changes in about 2006, 2007, as I said. But look at what we've got in these 2 years here. 2011, 2012 turn out to be the biggies. The first thing that happens is that IANA, the organization that hands out IP addresses to routing registries. Here in North America, we use ARIN. In Europe, use RIPE. In Africa, use AFRINIC. 5 different registries. It handed out the last block of IP addresses to those registries. The first of really 3 or 4 stages of IP address runout. The first is at the high level. And by the way, the allocations from IANA are /8s of space. So a number .000. And that's then broken up to the requests that come out from members of the RIR, whether it be a broadband, or a hosting company, or a wireless company, or a small ISP. That's the second level of runout. And ARIN's very close here. Asia Pacific already ran out over a year ago. RIPE ran out about a month and a half ago. And ARIN is sort of holding as best it can that line of making sure it doesn't run out too quickly, predominantly to reinforce the message that v4 space is truly out. The second thing that happened in 2011 is World v6 Day, where we did an experiment where we decided to turn on v6 on major websites for 24 hours only and measure what broke. You'll see some stuff about that. And then finally in 2012, in June, we ended up with World v6 launch, where that experiment, I'll give you a hint, was quite successful. So a year later, we turned it on for real. So, blah, 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 network map, blah, blah, blah. Again, you have to have one of these in a presentation. But there's actually some key points about this. If you look at 2012, you will see if you replace all these dots with remove our network from this, and say, okay, where are the internet peering points? Where are all the other networks, whether they be in Europe or the US? If I go down to Latin America and look at that, if I go into Australia, New Zealand, if I go into the Middle East to a lesser extent, what you find is you find networks running v6. You see the core of the networks running v6 far more so than the edge. So we've got a couple of numbers that will help us have a look at this. And the whole goal here, there's actually really, there's many goals, but one of the goals that comes out of this is the realization that v6 really does exist in the real world, and that it needs to be it needs to be used. And if you can't get access to it from your service provider, well, maybe pick a different service provider. So this is the first of the graphs, and there's a lot to learn from this graph. First off, I mean, this is a daily report that's been going forever and a year, and it gives an idea of the number of internet autonomous systems, the number of different networks. So a big backbone like a Comcast or AT&T or a Cox or Time Warner or whatever are all AS numbers. The internet is a collection of AS numbers, 40-odd thousand AS numbers that are active at any one time. The word internet means the interconnection of different networks. Each one of those ASs can be measured to see whether it has v6 capability or not. And it's measured, we measure it every day, and then we graph it. And the graph is going up. It's the first of the up and to the right graphs, and that's good. Here's February 3rd of, sorry, there's actually something amazingly wrong with the dates on this. I updated it just before I presented it. Pretend that that is +4 there. That should be 2008, and that should be 2012. How very strange. Very strange indeed. Okay, so this is February of 2011, and IANA announces it's run out of v4 addresses. Now, that announcement eclipsed anything else that anybody did when they said, you should be looking at IPv6. The amount of people that suddenly turned around and said, I need to look at IPv6, at that point was massive. It hit the popular press. It hit Wired magazine, boring. It hit New Scientist. Okay, that's sort of interesting. It hit The Economist. It hit the Wall Street Journal. It hit the NPR business program. This meant that it had jumped the chasm from just the techies and the internet guys into looking at where the real world had issues. So what happened was we started getting a bit of an uptick in interest and implementation on v6. When we announced World v6 Day, which was going to be in June of 2011, ignore the horizontal scale here, you realize that we really had been growing because this was a one-day test. And then things sort of leveled off a little bit. And you can argue that there are two reasons for that. One is that Europe goes on vacation. Don't ever try and implement networks in July or August in Europe. It doesn't work. And secondly, the gun to the head had disappeared. It was interesting to talk to CIOs who actually looked at World v6 Day, read about it in the popular press, read about it in all manner of different media, and thought of it as a Y2K event. Oh, we must be ready for v6 on that day, just in the same way that Y2K was a absolute, point in time. The fact that most people thought it was midnight and not realize that it was 0 UTC, that's pretty humorous, but, move on. This year in 2012, we ended up with World v6 launch. I'm going to talk a little bit more about what that is, but the good news is you can see we got that graph to go back up again. Yes, it's sort of flattened off a little bit. But if you actually measure the absolute numbers here, when running at 14+% of all the ASs in the world, just running v6, 14% is an amazingly low number. But you've got to remember that 3.6% is an even lower number. And it isn't worth having this graph go out all the way. It's flat and boring. The good news is that of that 14%, we end up with a good core of networks. Anybody here has got a latest and greatest Verizon HTC phone that runs 4G? Then your IP address that you get when you're roaming in a 4G city is in fact on a network that's v6 enabled. And if you've got the right phone, like the first one was the HTC Thunderbolt, but the newer ones are the same, you actually get a v6 address on that phone. So, and there's some subtlety to that v6 address that you get, which I'll talk about later. Bottom line is, you hold a gun to people's heads and things happened. Let's look at the second graph. So this is sort of a different way of looking at it, but just looking at the routing table. The routing table truly tells us whether we can use v6 in the global internet. And the bottom line is both these graphs are up and to the right. This is a good thing. But this is routing. So let's look at something more interesting. Let's look at traffic. And traffic really gives us an idea whether end users are actually using v6. And if end users are using v6, then the whole plethora of elements that can talk v6 from the consumer side back to the servers really seems to play pretty well. So the first thing to do is to go back a year and look at what happened on June in 2011. 24-hour period defined as World v6 Day. Started at 0 UTC. So that would be 5 o'clock in the evening in California, 8 o'clock in the evening here in the East Coast. And the traffic, this is purely the graph of flow traffic, of web traffic, port 80, port 443, over a period of time. Instant jump. Because what World v6 Day was about was coordinating major websites to turn on their DNS with a Quad A record to say they could deliver v6 to their website at 0 UTC. And the reason it was done as a coordinated effort is because if just Google did it and not Facebook, or Yahoo did it and not Microsoft, or one company did it and not the other, and it had a problem, then someone would turn around and go, well, you know, Google's down, but Bing still works, so off they moved to Bing. The goal was turn them all on at the same time, because then people realize, you know, Bing isn't working, and Yahoo isn't working, and Google isn't working, and Facebook isn't working. Maybe I've got a problem, not them. And that was the key point to get across, that if turning on v6 on the mass internet for heavy use sites, and you have a big percentage of traffic and big percentage of user base once you hit those key sites, then you end up being able to get a message back to the consumer base and maybe to the service provider, the broadband service providers, hey, there's a problem. Now, it actually turns out there wasn't. There are an amazingly few number of, and I mean few as in not even 5, documented cases of somebody picking up the phone and phoning their service provider and saying, we have a problem. And the service provider working through, because we knew what all the problems were. There were some well-known problems that would cause v6 failure. But the cool thing about this is, first of all, this part of the graph. This is classic user base traffic, users going to sleep, users waking up, users going home and doing more, et cetera, et cetera. That traffic caused predominantly out of Europe. Pretty much one of the interesting things that comes out of this is that there's more consumer eyeballs running v6 in Europe than anywhere else in the world. The US may well come back into a good position with some of the work that's being done by AT&T. But the reality is that Europe absolutely stole the show a year plus ago. But look at what happened here. This 24 hours was so successful that Google decided that they were going to leave the video streaming, that's the back-end delivery of bits inside the YouTube video, they were going to leave that turned on with v6. They weren't seeing problems. Now, the basic calculation out of Google is very simple. Go look at how much revenue they get on a yearly basis, divide that by 365, you get how much revenue they make in a day. Assume a 1% failure, and that's more money than we're all earning collectively in this room. So a 1% failure would cause a problem financially for Google. Well, there wasn't a problem, and they left it on. It was probably the best indication that v6 had come of age. But this was a year ago, a year and a half ago now, in fact. So let's look at what happened this June. And this June was much more interesting. This June, we said, look, we've got to take this v6 thing seriously. This time, we're going to turn on v6 on these websites, and we're going to leave it on. Done. Finished. This means sites like Google, Facebook, Bing, Yahoo, and many, many more are v6 enabled right now and are going to stay that way. And if there is a problem, the problem is to be solved on the consumer side, and it's considered that there isn't that much of a problem. So what you end up with here is you see the jump in World v6 Day. This is all a one-year graph, so this you lose the peak from averaging. But World v6 launch was about being ready on a particular day, not about turning on that day. So this little jump here and this jump here and all these other jumps is the back-end CDNs with inside Facebook or Google turning on another section of their files. Then you've got a section of a jump like Netflix turning on v6. And Netflix in the US can actually account for 25 to 30% of bandwidth in the evening to certain consumer bases. It's a big, big jump. But the bottom line is that by that date you were done and ready, and it kept on moving. Let's look at some other graphs. Let's look further on. This is a fresh graph. This is the Deutsche, this is Frankfurt DKIC's Internet Exchange, and you can see that if you ignore the peak for a second, you can see that by May and June we had a nice steady increase in just the v6 traffic. Now this exchange moves terabits of traffic. So to discuss 20 or 30 gigs worth of traffic when you're discussing a terabit plus of traffic, still a small percentage, but it's there. This is Amsterdam. It's definitely happening, but it's not as intense. This peak is a really interesting peak, and it shows probably one of the best reasons why v6 is being taken seriously on the global internet at the moment. The biggest reason is this was a routing mistake where v6 was going over a public infrastructure that could be measured versus a private set of fibers, a private interconnect between two networks. This is traffic actually destined for an ISP in Romania, which in about a year and a half ago decided they wanted to take v6 seriously. And there's a million plus and growing consumers that have IPv6 capability to the home in Romania. Why Romania? Somebody decided it was a good idea, and it is. So let's just go through a couple of other things. So this is the key takeaway. If you're talking about the global internet and v6, then you're dealing with one subtle issue. The v4 path is changing. What we're used to today in a nice, clean internet to the broadband user, even to a lesser extent to the enterprise user, they won't get as affected at this, is the fact that because of the run out of IPv4 addresses, the large broadband user base, and that's the Time Warners, the Comcasts, the Coxes, the Verizons, the AT&Ts, and more, those are going to start implementing carrier-grade NAT, CGNs, as a solution to a lack of IPs. There is a lack of IPs, and there's nothing it's numeric. We run out. So the reality is this, that the IPv4 path ends up going via a network address translation, a carrier-based network address translation, which means that if you're trying to do protocols, and SIP's one of them, where NAT is not your friend, you now have the potential of two NATs, one inside the carrier and one inside the end user CPE. So when you look at this, you realize that the v6 path has not only a win from a longevity of IPs, but it also has a win from the fact that it isn't sitting there with an interim box. Go back to that mobile example, and I use Verizon as an example, but we could use T-Mobile and the like. In the environment that if you pick up your smartphone, pick up your iPad, run it on 3G, probably not in this room, that you realize that you're actually not connected directly to the internet. You're connected through a proxy somewhere. In fact, half of the AT&T traffic comes through Atlanta or Phoenix or Seattle or somewhere. In the v6 world, it turns out when you play around in the v6 LTE environment, you actually get a native IPv6 address that has direct 100% connectivity. And if you go talk to the people at T-Mobile and you talk to the people at Facebook, when they implement this on their 3G environment and now on their 4G environment, in that example, that one-to-one NAT-less connection without even a proxy, filtered and firewalled but not proxied, means that things like the back end to, let's say, a Facebook app, which is predominantly a set of API calls, runs way, way faster. Not hard to do, again, a quick Google search on carrier-grade NATs and what the detrimental effect is to certain protocols. If you're running an Xbox 360, you won't be happy either. Anything that's in the gaming world has a problem. Anything inside, well, the SIP world has the same type of issues. All right, so very quickly, how do you even motivate people to go get interested in v6? I'm going to give you a bit of a history lesson, but it's a good, nice twist to it. So we did two things. We did this tunnel broker, which is now used by, not quite hundreds of thousands of people, but we'll break that 100,000 number at some point. But the goal is not to. Tunnel broker was to get people access to v6 if their service provider couldn't give it to them, because there was this absolute need to get software developers access to v6 and to understand, what this felt like, and it's very easy to set up. The second thing is we did this certification program, purely soft, purely online. If you're running a network, if you're running servers, go give it a try. It's got a nice little twist to it. So the certification program, blah, 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 lots of questions, not complicated. But it isn't really questions. It's a set of practical things. Can you access a web page and read a token off it in v6? Can you do a ping or a trace route in v6? Can you receive an email in v6? So as you go through this testing, the goal was to convince system administrators to actually finish off their v6 configuration, which on a modern operating system is nearly out of the box, quite frankly. And my best test for this is that you can get this thing done anywhere from half an hour to 3 hours, depending upon how well set up you are, or it can take you a while. But we go through a whole bunch of different tests from name servers and we have just different levels of certification. Here's an example of one of the tests. It's many, many steps, but this simply says here, we want to send you an email and we want you to receive it via a v6 connection. And if you can do that, then we can tick off that you have a mail system that's up and running with v6. But doing a test and talking about it and all that good stuff really just doesn't help, because you can yak on about something that's front and center is important and people will still ignore you. So how do you get around that problem? And the answer is a T-shirt. So you can talk about technology, you can talk about all this testing, you can talk about enormous amounts of testing and deployment, and it boils down to this. You go and announce that you can do, you'll hand out a free T-shirt if you pass this certification test, which essentially means you're going to take your network and your web services and your name server and you're going to enable v6 on it. So 5,500 T-shirts later, which have gone out to just about, well, not just about, every time zone in the world, every continent in the world outside of Antarctica. And we've shipped these shirts, and we think we're now responsible for getting a hell of a lot of people actually motivated to do v6. There's some subtleties about this testing. The final test that you had to do in order to get this T-shirt was to get your domain name registrar, a VeriSign or a GoDaddy or whoever you use, to actually put in the v6 address of your name servers. And back when we did this 2 years ago, none of them would do it. GoDaddy actually sort of did it after a while. VeriSign, the old sort of network solutions guys, did not do it. So basically, we ended up crowdsourcing thousands of people to solve this problem around the world. And the good news is that you can now go out and the full chain and get v6 from everything from name servers to web servers and everything else in that. The T-shirt is that, well, that's what it is at the back of it. It's very geeky. Anybody who actually wants a T-shirt with RFCs on it and other stuff on it, but you know the audience. All right, final graph. I talked about final slide, final graph. The big story about v6 is very simple. It has finally happened. It's up and to the right with just about every graph, whichever way you measure it. If you're doing equipment that's hitting the consumer base, if you're doing software that hits the consumer base, you will see v6 in the path. You may not see it today, but you will see it. And you will see the v4 path become a more and more detrimental path over time. It's just guaranteed. The law of numbers says that's going to happen. If the only takeaway is that you go up and do some research on v6, then I've done my job for the day. That's the last slide, and thank you very much. And I don't know how. Do we have time for questions or? 2 minutes. Absolutely correct. And there is really multiple steps to make that work. The carrier itself has to implement v6 within inside its core network. It has to implement it within inside the head end if it's a cable, or inside the DSLAM if it's a DSL, or if it's a fiber to the home inside or fiber to the curb inside the delivery to the home. And then there's the CPE. So go to Best Buy, go to Fry's, go to wherever you want to buy, or Amazon online, or it doesn't matter where you go, and go look and see whether the CPE that you would think you want to buy actually says it runs v6. And that has been the hardest part of the equation. And it's been addressed in different ways in different parts of the world. In the US, you buy internet service and then you sort of go off to the store and buy yourself an interface box, a wireless router. In Europe and in some parts of Asia, that's part of the telco service. So there's much more control. So there's many, many moving points, but it's happening. When you've got 1 million, so we went from the beginning of the year with nobody to 1 million plus AT&T Universe subscribers who have no idea, but they've just been upgraded to v6. And the final point is, keep in mind that the internet, when we talk about buying internet service, we buy internet service as access to the internet, and there's sort of a full stop at the end there. And that internet's going to change from just being v4 to being v4 and v6. So you go back to your carrier, go back to your enterprise provider, go back to your hosting provider and say, you know, I need it all.
Time for one more question.
All right, I've got a question for the audience then. Put your hands up if you've done any form of implementation of v6 on your networks or anything at the moment. All right, got a third of the hands up. One guy going like this. This is the guy we got to work on. But the rest of you, do the research. This will become front and center. It will become front and center quicker than you imagine.
Let's thank Martin again. Thank you.